Hi everyone. My name is Hever, and for the past couple of years, I've been exploring the field of speech recognition from various perspectives. And today, I'll be sharing with you insights into this area and its connection to related fields, such as particularly NLP that you've been talking about it previously with Miriam. Um, and basically, I have a strong passion for working with data we generate as humans, such speech and text. And I find it really fascinating to delve into the unique insights we can extract from our own data. And I hope that after this talk, you will feel the same. So 6 years ago, I founded Data Nights community for women in data science. So it's just a short anecdote. You can scan the barcode and follow our future events and courses. Um, and here is what we will cover today. We will have a short and quick intro to speech recognition and conversational AI. Then we will dive into the detail. We have just 30 minutes, but we will see how it works and how we can build our own app with no code apps by ourselves. We will explore some of the hurdles it handles with, and finally, we will discuss where this technology is heading and how you can use this data for building new cool applications and innovations. So, in today's landscape, many of us utilize with virtual assistants like Siri in our smartphones or Alexa in our houses. And this is a good example of conversational AI, which facilitates the communication between humans and machines and devices around us. And today I would like to focus on an underlying mission related to conversational AI called automatic speech recognition. I will refer it as ASR moving forward. And so ASR technologies enable computers to translate spoken language into text. So, another short anecdote. Please take a moment and complete the sentence, or you can write in the chat down below what do you think is the right answer. So, some of you may be surprised, but approximately a quarter of our internet searches are conducted using voice queries, which is quite a lot. Okay, so let's dive a bit deeper and understand the differences between spoken language versus text. And compared to text, voice signal is not always consistently defined. Sound clips containing the same information can vary significantly. And for example, consider the word hello. If it's spoken quickly, it may take a second, but uh, if, for example, here Mr. Slow will say hello, it could take up to 5 seconds. So this is just an example for that. Another thing is the complexity of isolating speech in a noisy environment. For instance, if we capture a piece of speech in a setting where multiple people are talking, cocktail party, cars, passing by, babies crying, etc., separating the speech from the background noise becomes a challenging task. And also switching the microphones um, can be crucial. New microphones might have filters that capture acoustic differently or emphasizing certain frequencies or reducing others. And another thing is the microphone positioning, speaking directly into the microphone versus at an angle or whatever, it can also impact how the data is processed. Um, so, what is the ideal ASR system? So, we aim to develop an ASR system that effectively handle a spontaneous speech, for example, different accents, background noise, and furthermore, the system should be also designed to include a wide range of speakers without relying on the unique features and characteristics of any individual speaker. So, why did I call it a system? The entire mechanism is processing the data in stages and using various algorithms. And initially, we apply voice activity detection to identify speech segments and separate them from silent intervals. So this is the first step, and following this, we utilize the diarization algorithm, which segments the audio and classifies it by speaker. And this allows us to determine which segment correspond to speaker A, for example, and speaker B. And then each separated audio is processed through other techniques such as echo cancellation or noise reduction. It depends on the environment. And just in the end, it enters into the speech to text algorithm, which transcribe the spoken content into text, basically. Then you will come and tell me, Gal, it is really fascinating and cool and whatever, but I'm not a techie person and I want to start working on my idea as soon as possible. And I'll tell you, no problem. There are many solutions for that. But first, you need to define your task properly. And you need to understand the project and the purpose and the challenges that you are going to solve. And the next step will focus on collecting the data set. You will need to gather data that is relevant to your application. And for example, if you want to build a speech command model to identify a certain word, so you will need to record many people saying this word. Okay, so it looks really simple, gathering or collecting data, but actually it's not so simple. And there are a few things that you need to take care of or think of when you are collecting the data and training the model. So the first thing is diversity. For example, out of 1.5 billion people who speak English, just less than 400 million of them use it as a first language. And that means that over 1 billion speak it as a secondary language with different speaking styles and pronunciation due to demographics and etc. And given that fact, language sounds a bit different and it always changes. And another thing that is that new generation pronounce existing words differently. Slang, informal phrases like we have, for example, ChatGPT. We didn't know what is ChatGPT until last year. And that means that benchmarks and data sets and ASR systems should constantly have to adapt themselves to the latest versions. Then splitting the data into train and test sets, of course, and put this data in the no-code platform for creating the model. So there are quite a lot of no-code applications enable no techie people or you building your own application. Uh, or basically you can combine a few of them if you use one for building the model or and the other one for building the software. So you can use OpenAI, Bubble, for example, Teachable Machine, Pico Voice, uh, and then Glitch for the for programming the application. So let's see some example. It's just a simple drag and drop.
Hi, in this video, we are going to look at the audio model in Teachable Machine. So far, we've only looked at images, but you may have noticed you click Get Started, and in the middle, there's Audio Project. So we'll click on that. Looks exactly the same as the image classification, except that it loads with this extra class already labeled as background noise. So in this model, we're going to build a model to differentiate between me and Dr. J's voices. And the microphone will always be listening to us when we test our model. So we need a class to tell us when
neither of us is talking.
Neither of us is talking, which is background noise. And you will do this too. So we have to record for a minimum of 20 seconds.
Then basically here the training classifier, but you can also use it for speech command and for the hello that we talked about it before. So you can build few cubes here. Each one will extract different features for each one of your speech commands.
Of background noise to make this work.
Here, just recording the background noise. Oh, just a moment.
Hi, in the button, extract samples. And that's going to take these 1 second samples.
We didn't talk about this stage of extracting the samples into spectrograms because we don't have too much time, but this is what they're doing.
Chop them up and then place them as your audio samples in this class of background noise. And actually, you can start to see these are pretty dim, but these are actually spectrograms, visualizations of the audio in the background noise. You'll see more of this with our second class. So we'll do me first. And for this one, you do the same thing, except you want to have samples of the person actually talking. So you just hit your record button, and then you can recite a poem, or you can do this again, try to get at least 20 samples. Now, one more time. Well,
for the second class?
And
sorry, I ruined it for you.
okay, so if that happens, not a big deal. You just hit record again, and you don't have to extract any samples. Keep it, but we don't want that because it had Professor Switch. This time, you want to do this. By the way, you don't have to do just different people. You can, and I'll do one more time where I'm talking. Maybe you want to talk at a high. Really good to show factors of
so many things. Like
now they're going to train the model.
Higher pitch, lower pitch. You said volume.
Right. But for the sake of purposes for showing this, we're going to train.
Push
The most
button
important
and
thing is that you
training.
keep this tab open while it's training.
This is so hard for me. So is it true that what's happening here is that the audio was
Energy of the frequency waves.
Now
And then when we hit training, we're training a neural network to adjust its patterns in order to do that. So now when I'm talking, it's recognizing me as speaking in real time.
I think it's actually doing a pretty good job. It jumped the peak.
So basically, it's really, really.
Bar. Hi, in this video, we are going to look at the.
And
hi, in this video.
Okay, so you can train the model as we saw using the platform. And the last step is testing and evaluating the performances. So how can we do that? The most common metric is to evaluate the model with a word error rate metric. And this metric is similar to accuracy, but defines certain components a bit differently. S, for example, is the number of word substitutions that's made by the model, like here, news and moose. And D is the number of words that weren't recognized or produced properly by the model. like get it done, and the it left out in the output. And I is the number of additional or incorrect words inserted by the model. And the last one is C, that represent the total number of words that were recognized correctly. And in the end, we just sum all of the S, D, and I and divide it by N. That represents basically the total the total words in the inference. Uh, okay, so voice data contains a rich set of features that we can extract and analyze. Uh, but the ASR mission, the ASR model get millions of audio snippets and produce in text, but do not take the advantage of all the abundance of information that basically exists in the signal. Only 7% of the human communication is made up of the words we say, uh, and rest is how we say it, using the tone of voice and the body language, etc. And so let's see a few examples. Let's listen to the next audio recording and try to guess who is talking. Okay?
Happened.
Oh, well, it's really quite funny. I was in bed sleeping at 2 o'clock this morning. My wife comes in and says, "Oh, the shop's been, someone ran into the shop." And I said, "Oh, what?" So I jumped out of bed and all I had was my undies on, and I've walked out the front and I've seen the car smashed, and I've seen the bloke walking back to the car. And so I've walked outside and I said, "Oh, what are you doing, mate? Like, you can't be leaving."
So you can unmute yourself and just describe the character of the person that in the audio. Or just write down in the chat. Right? Aussie, Irish. So we will find out soon. Okay, so we can also guess what is the gender of the person just based on the pitch, right? So this is a male, and basically based on the vocal cord, we can also approximate more or less his age, maybe around 30, 35, I think. And about the region, most of you say Aussie. So yeah, also the accent and the dialect can expose the origin country. Uh, and this is the guy. Let's see it again.
Happened.
Oh, well, it's really quite funny. I was in bed sleeping at 2 o'clock this morning. My wife comes in and says, "Oh, the shop's been, someone ran into the shop." And I said, "Oh, what?" So I jumped out of bed and all I had was my undies on, and I've walked out the front and I've seen the car.
So basically, you were right.
Happened.
Oh, well, it's really quite.
So this is just one thing, but there are many more characteristics that we can extract from voice. For example, we can also detect illnesses like Parkinson, ALS, COVID. Maybe you also heard my voice. I have a cold today, and because of my hoarse voice and the blocked nose, it's a bit changing my voice. So health condition is another thing. A slower speech rate can indicate tiredness. For example, if you are building an app that scores the ability uh, of a person to drive the car, and it can also be relevant. And we can try to reconstruct the face structure from pitch, maybe narrow noses versus thick noses, change the pitch levels and the tone of voice. And it can also be really interesting to do more research about it. We can also try to discover relationships and maybe to identify emergency cases and distress situations, or mental health and emotions, etc., etc. You can do your own research, and you may build a multimodal algorithm that uses text, voice, video, um, and lots of information in one cube, that utilize the whole information, the whole data, to build your own application that solves a certain task. So I hope that I've convinced you that working with voice is really useful and interesting. And we saw that ASR is pervasive in our daily lives, and we frequently interact with our devices using voice commands. And now it's basically your turn to create and use the plenty of no-code AI tools um, to develop your own application. And that's it. I hope that this lecture caught you well and it was beneficial for you. And if you have any question, feel free to reach out here or later, or ask more questions in the chat.
Thank you so much, God. Thank you so much. I just
Thanks,
wrote
Noam.
something that we've discussed earlier, and that's like a cool anecdote about Freddie Mercury and Steven Tyler, and also Mick Jagger. They all have really, really, really big mouths and lots of
Yeah.
teeth, and it probably is related to their vocal incredible vocal abilities.
You are absolutely right. And maybe also spoofing or other tasks can use it to, you can extract more characteristics from just the face structure, and maybe find out if this recording or snippets is fraud or not, or many other tasks. So be creative, but you know there's lots of characteristics that we can utilize from this, and maybe you will have the next innovation, and your the future startup that change the world.